In this video, let's write some code for variables. So let's quickly get started. I'll start with adding our header file. So I'll write hash include iostream. Then let's include, or let's use namespace std. So I'll write using namespace std. And then let's write the main function, int main, return 0 at the end. And our code goes here. Okay. So yeah, this is kind of a basic template that we have to follow everywhere. Now what we'll do is we'll first create variables. So we have seen syntax for creating a variable. We have to write data type keyword for the data type of which we have to create a variable, and then we have to write name of the variable. So let's create variables of different data types. Let's start with creating a variable of integer data type. So I'll write int keyword, which is keyword for integer data type, and I'll write name of the variable. Let me write name as, let's say, I underscore var. Then I'll write semicolon. See, always remember, you have to end a statement or you have to end a line with semicolon. Now let's create a variable for characters. So I'll write char, let's say c underscore var. Let's create variable for float. So I'll write float f underscore var. Let's say create for double. So double d underscore var. And let's create one for boolean. So I'll write bool b underscore var. Now we also have one more data type in primitive data type category, that is void. But there is one very important thing about the void data type, that is you cannot create variables for void data type. Void indicates no data. It indicates absence of data. So that's why we cannot create variable of such type. Okay. Now what we'll do is we have created 5 different variable: integer, character, float, double, bool variable. What we'll do now is we'll print what is present inside each and every variable. So we'll print content of each and every variable now. So how we can do that? So for that I'll use cout statement. Then after that I will have to write left triangular brackets, and then in the previous code what we have done is we have printed constants. So how we print constant? We just write constant value over here and then it will be printed on the screen. Now in order to print variable data or content of the variable on the screen, what you have to do is you have to write variable name over here. So let's say I want to print what is present inside ivar. So what I'll do is I'll write I underscore var over here. So content of I underscore var will be printed on the screen. Let's do it for other variables as well. So I'll write cout c underscore var. See, I am writing cout multiple times. In each cout I am printing value of one variable. Okay, you can also club multiple cout together and you can write entire thing in a single line. So let's try it out as well. So what I'll do is I'll write cout over here, and let's say I want to print value of f underscore var. So I'll write f underscore var. Then after printing value of f underscore var, let's say I want to give new line. So I'll write endl over here. Then after giving endl on the new line, let's say I want to print value of dvar. So I'll write dvar. So I'm just clubbing the variables with the help of this left triangular bracket. After dvar, let's say I want to give new line. So this time I'll use different syntax. For new line I'll write in double quotes, I'll write /n. And after dvar, let's say I want to print value of bvar. So I'll do it over here, and then over here I'll write endl. Let's also put endl over here as well. So I'll write endl on new line also over here. Okay, so awesome. So what we have done so far, we have created 5 different variables, and now over here we are printing their content. Let's quickly compile and execute this code, and let's see what we are getting as the output. It is very interesting. So let me just compile this code. So I'll write g++ followed by name of the file. So in this case, name of the file is 02 underscore variables.cpp. Let's compile this. You can see the code has got compiled, and we have got a.out file, which is our executable file. So I'll just execute this file. So I'll write ./a.out, and you can see over here. See over here for ivar it is printing 253713200. Now from where this value is coming, we are not sure about this, right? That's why these kind of values are called as garbage value. We can't predict these values. So if I run it multiple times, you can see every time we are getting some different value. See, you can see over here we are getting different value, over here we are getting different value, over here we are getting different value. So these kind of values cannot be predicted. That's why such kind of values are called as garbage value. So if you don't initialize your variables, if you keep them uninitialized, then in that case they are going to hold some garbage value. That's why it's always recommended to initialize them. So how we can initialize a variable? We have seen the syntax for initializing the variable. So after writing variable name, you have to write equal to, and then after that you have to write the value or the constant that you want to put in that variable. Let's say you want to initialize iVar with 10, you can write equal to 10 over here. Let's initialize cvar with, let's say, small a. Let's initialize fvar with 96.5 f, which is a floating point constant. Let's initialize dvar with, let's say, 101.56, and let's initialize bvar with, let's say, true. That's it. Okay, now we have kind of initialized all the variables. We have initialized all these 5 variables. So now let's clear the terminal and let's compile and execute this code again. Let's see what we get as the output this time. So you can see that in this case we are getting the values with which we have initialized our variables. So whenever we are printing iVar, we are getting 10. Then for cvar we are getting small a. For fvar we are getting 96.5. For dvar we are getting 101.56. For bvar we are getting 1. See, true is used for boolean constant. It indicates boolean constant. But internally, whenever we assign true to any boolean variable, internally the value which is being stored is actually 1. I told you in the initial video of data types that in boolean data type we have two values, 0 and 1. 0 indicates false, 1 indicates true value. Okay, so whenever you assign true to any boolean variable and whenever you will print that boolean variable, it will print 1 on the screen if you are assigning true. It will print 0 on the screen if you are assigning false to that variable. So in this way it will work. Now let's say after printing this value, let's say you want to modify value of some variable. Let's say you want to modify value of, let's say, iVar. How you can do that? So in order to modify value of iVar, what you have to do is you have to write I_var, let's say, is equal to new value. Let's say you want to initialize it with 20. So you can write I_var is equal to 20. See, over here you don't have to write int again. This is invalid syntax. You don't have to write int again. If you write int again over here, and if I compile this code, you can see we'll get some error. Compiler or C++ compiler is saying that error redeclaration of int iVar. So basically if you write int over here, what this will mean is you are again trying to create a variable with name I_var, and the compiler is now saying that we already have one variable with name I_var, so you cannot have again another variable with same name, that is I_var. But let's say instead of writing I_var, let's say you write I_var1 over here, then that will absolutely work, because in this case what is going to happen is this I_var is going to be one separate variable and this is another variable which is being created. But let's say if you want to modify the same variable, then what you have to do is you just have to write I_var, which is name of the existing variable, is equal to the new value that you want to give. And this operation is called as assignment operation. Okay, so this is assignment and this thing is called as initialization. Now one quick important small concept that I want to tell you over here. See, this thing which I have written over here, this is called as comment. So usually we programmer use comments for, you know, understanding of our code, to elaborate few things about the code. Let's say you are writing one code and that code is going to be shared with some different programmer, and you want to tell some programmer that why you have written this line, so you can do it with the help of comment. See, the comments are just for programmers understanding. Compiler is not going to look at the comment, so they are just for the programmer's perspective. They're just for the sake of programmer. Compiler is going to ignore them. It's not going to care about the comments. It's just for the programmer. So how we can write a comment? You have to write // and then you can write whatever thing you have to write, whatever message you have to write. Actually, there are two types of comment. One is single line comment. So this comment that we have written is a single line comment. So in this kind of comment, you can write thing in only one line. You cannot break it in multiple lines. And we have one more type of comment which is called as multi-line comment. So let's say you want to write multiple lines. Let's say you want to write a big note and it's going to consume multiple lines. So you also have multi-line comment. So how you can write multi-line comment? It's very simple. You have to write one forward slash followed by star, then you can write whatever content you want to write as a comment, as a note, and then you have to write star again, and then again you have to write forward slash. This is called as multi-line comment. So this is single line comment. This comment spans for only single line, and this is multi-line comment. Why we use comments? Whenever we want to elaborate any part of our code, whenever we want, see, sometimes this happens, we write some code and in future, let's say after 2 months, we forgot why we have written this part or why we have done it in this way only. So in order to elaborate such thing, you can write it using comments. Comments are just for the programmer. Compiler has no use of comment. Compiler is going to ignore the comments when it executes your code. So yeah, I mean, that's about the comments. Let me just remove this. Okay, so now we have seen how we can create a variable. We have also seen how we can initialize a variable, and we have also seen how we can modify value of a variable.